Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, functions in mathematics, what we are going to discuss today is the largest domain of a given function. So let's begin. After completing the very lesson, my dear student will be able to find the largest domain of a given function. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in a favorite segment of the lesson today, I'll give you another interesting number. This number is 25. 25 is so special, so unique. I will explain what is special with this very number after completing my lesson today, so don't go away. Now, to begin the lesson, my dear student, let me first define what is largest domain of a given function. The largest domain of a given function is the set of all the real numbers for which that very expression. The expression here refers to the formula that defines the given function. So when you substitute all those set of real numbers in the formula, and the final value will also be a real number. So those set of values will now comprise members in the largest domain. We are going to take examples how we can make use of this definition for some functions and find their largest domain. So let's just move and take examples. Example number 1, it says let the function f from x. So x is your domain. R is your codomain. This R is now the set of real numbers. And this function f is defined by the formula f of x equals to square root of x plus 4. The question asked here is to find the largest domain. That is, we should try to make this x as large as possible. As large as possible. The largest possible value for this x, that is your domain, will now be set of real numbers. But of course, some values in the real numbers will not have an image when substituted in this very function due to some reasons which we shall see. So it is those values that we have to eliminate from the set of real numbers, those values that didn't give a result as a real number after substituting in this very function, because remember our codomain is set of real numbers. So if I pick all the real numbers substituted here, some will not have an image in this codomain. So it is those that we have to eliminate from the set of real numbers. What remains will now be the largest domain. So let's just find out. Solution to this very problem. Looking at the formula, looking at this, the definition of the function f of x equals to square root of x plus 4. What will now come to your mind if square root of a negative number? So you now think, what are the possible values of x that when substituted there, this inside the square root will be a negative number. It is those values that you have to remove from set of real numbers to get the largest possible domain. So let's just consider this two values, minus 5 and minus 6. Let me just try minus 5 and minus 6 in this formula and see what will happen. So substituting x by minus 5 in the formula, I now have, I'm now trying to find the image of this minus 5. So I'll now replace the x by minus 5 in this formula. So I'm going to have square root of minus 5 plus 4. And minus 5 plus 4 will give answer minus 1. And you can see root of minus 1 would not be an element in the set of codomain, because this is not a real number. So if you now take minus 5 and want to find its image in the codomain, you won't see that very image. And remember, for f to be a function, all the elements in your very first set, that is in the domain, must be assigned to a single element in the codomain. So to that, this minus 5 will not have an image in the codomain, which is a set of real numbers, because this square root of minus 1 is not a real number. It's a complex number. So which means this would now be one of those numbers that will now be removed to get your largest domain. Let me try minus 6. Image of minus 6 is what I wanted to find. So I'll now replace the x by minus 6 in the given formula. That will now be the square root of minus 6 plus 4. And square root of minus 6 plus 4 is nothing but square root of minus 2. You can see it's a square root of a negative number, which doesn't exist in the real plane, meaning it's not a real number. So which means minus 6 also will not have an image in this codomain. and it must have an image for f to be a function. If I take even f of minus 7, it will still give me another negative square root. So all those numbers that are negative, that are smaller than minus 4, will not have an image in the codomain. So if I should make my domain as large as possible, based on just these two that I have seen, so it is those set of values that I have now removed from set of real numbers to get my largest domain. Therefore, the largest domain would now be set of real numbers, but excluding all those negative numbers less than minus 4. So let me just write my largest domain. My largest domain will now start from minus 4, minus 3, minus 2, minus 1, 0, 1, 2, up to whatever number, no matter how big it is, provided it is positive. The only negative numbers allowed to be part of your domain will now start from minus 4, minus 3. Anything smaller than minus 4, that very element will not have an image in the codomain. So this is the largest domain for this very function. Let's just move and take another example. Example number 2 says let this very function g that has a domain x and has a codomain set of real numbers, and this function g is defined by the formula g of x equals to 1 over x minus 3. The question asks is to find the largest domain. So solution to this very problem. So the concept is clear. What you need to do, the largest possible domain may be the set of real numbers, but some values in the real numbers would not have an image because of some reason for some functions. And if you have a function like this 1 over, meaning algebraic fraction, what will now come to your mind is having 0 at the denominator level, because dividing by 0 is not allowed. It leads to something that is what we call undefined. So this is what you come to your mind. What could be the possible value of x that makes this denominator 0 if you have something like this that is algebraic fraction? So let's just consider some values. Consider x to be equals to 3. If I take x as 3, so substituting x by 3 in the given function, that is I want to find the image of 3. I'll now substitute x by 3 in this very formula. So I'm going to have 1 over, I replaced this x by 3, so 1 over 3 minus 3. And this gives you 1 over 0, and 1 over 0 is undefined. So this will not exist. You will not have an image of this very 3 in the set of codomain. And for this to be a function, each and every element in your domain must have assignation to a single element in the codomain. So to that, I'll have to remove this 3 from the set of real numbers to get my largest domain. All other real numbers, with the exception of this very 3, could be in the set of domain. So therefore, I will now write my largest domain will now be all the real numbers with the exception of this very 3. So I'm going to write it like this, starting from minus whatever number up to minus 2, minus 1, 0, 1, 2. You can see I have skipped 3. Then 4, 5, any other value, any other real number with the exception of 3 can have an image in this very function. So which means my largest possible domain will now be all the real numbers with the exception of this number 3. Let's just take one more example. Example number 3 says let this very function h that has x as domain and r that is set of real numbers as the codomain, and this function h is defined by the formula h of x equals to 3x squared minus 7x plus 4 all over x squared plus 2x minus 3. The question asked is to find also its largest domain. Solution to this very problem. This is similar to the previous example that we have just answered. When you have algebraic fraction, what will now come to your mind is having a denominator to be 0. If that denominator is 0, the entire fraction is now considered to be undefined. And if that is the case, which means the value that makes that denominator 0 will now be removed from the set of real numbers. The remaining set of real numbers will now make your largest domain. So let's just consider the denominator, this quadratic expression, for it to be 0. So if I now take that very denominator, that is x squared plus 2x minus 3 equals to 0. If I solve this, whatever value of x that will make this 0, it is those values that are now removed from set of real numbers. What remains will now be the largest domain. So solving this quadratic equation using factorization method, you now have that is the factorization of this will now be x plus 3 into x minus 1 equals to 0. If this is the case, then x will now be minus 3 or 1. That is, if x is minus 3, this quadratic equation is now 0. Or if x equals to 1, this quadratic equation will now be 0. So which means these are the two values that will make this denominator 0. To that, my largest domain is now going to be the set of real numbers excluding these two values, minus 3 and 1. Minus 3 and 1, because this denominator, if x takes this value or x takes this value, the denominator will eventually be 0 and the entire fraction will now be undefined. So let me just write it. So I'm going to have all the real numbers x such that x is not minus 3 and x is not equals to this one. But all other real numbers will now be members in the largest domain. This is how we now find the largest domain of a given function. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceful. And let me just move to the last segment, Mercy's fun, and explain what is interesting with the number 25. 25 is the smallest number, or is the smallest square number that can be written as sum of two squares. That is the smallest square number that can also be written as sum of two other square numbers. So let's just test and see. 25 is the same as 3 raised to 2 plus 4 raised to 2. 3 raised to 2 gives you 9 and 4 raised to 2 gives you 16. This 9 and 16 are square numbers, and if you add them, you get to your 25 back. So 25 is the smallest among the square numbers that can be expressed as sum of two other square numbers as well. So we see more of interesting things like this in mathematics in our subsequent lessons.